Hello, everyone, and thank you for joining this webinar about the role of research in data spaces and data ecosystems. The reason we're looking at this is because there has been a lot of discussion in the community, in the political sphere. For example, with Digital Europe, there's lots of discussion. There's also a lot of discussion by people in the cloud world, such as Gaia-X and IDSA, talking about data ecosystems and data spaces. So the question is what does this mean for researchers? What does this mean for research communities? And what are the points of intersection? I mean, obviously data sharing and exchange, which are the objectives of these data spaces, have always been an objective of research communities. So I guess you might be scratching your head to say, well, what is this? How is this different? What's new, et cetera? So what we're going to do is try to define data ecosystems and data spaces by a few key characteristics, which will help you compare what people are talking about outside of the research world, compare that to what you're doing in your own research communities. And we'll explore some of the approaches being used in several international research communities. I actually will cut that a little bit short because actually Andrea is going to talk very specifically about how data spaces are being implemented inside the AGIS environment. So certainly there are a lot of people, there are a lot of terms, they're not all exactly the same. So there are even questions of definition. So data sharing space, data spaces, open data ecosystems, data sharing domains. So what's the same and what's different? So we'll try to start by some definitions. So it seems useful, and based on an examination of how people are putting these data spaces together and talking about them, there are two basic kinds of definition. One is a data ecosystem, and the other is a data space, which in fact is the word that's being used by the European Commission. So a data ecosystem is a little more narrow than a data space. It is, we're defining it, and this is building on some of the literature, a purposeful collaboration or partnership, consuming, producing, and providing interoperable data and related resources. So interoperation is certainly very important. The idea that there are some specific parties involved, they're collaborating, they are forming a partnership, they have a purpose in doing this. We know that there are a lot of data ecosystems possible. So for example, even in the world of agriculture, there are already 7 or 8 data ecosystems that are in place and operating in the business world of agriculture, talking about how to share data amongst themselves. So this shares data from farmers, from farm equipment manufacturers, from farm cooperatives, agricultural cooperatives, various service providers, governments, et cetera. So all of these different names just connect: API, agro, DKE, agri-router, et cetera. They're all having an agricultural data ecosystem. And basically, science communities in different areas of research could really be considered as data ecosystems. So on top of the interoperability, most science communities are also trying to become fair. They're trying to fulfill the expectations or aspirations of the FAIR guiding principles. So findable, accessible, interoperable, certainly, and then reusable. Or they're working towards that in various ways. And not everybody is at the same place, and that's fine. So when we move to a data space and we look at the way the European Commission talks about a data space. So for example, in February of 2020, there was a document called the European Strategy for Data, and it talked about forming a common European data space. It also talked about creating 9 sectoral data spaces in different industrial sectors. However, they didn't define what data space was. So looking at the way the Commission, are using this phrase, we've come up with a definition. So it's a collection of FAIR, that's findable, accessible, interoperable, reusable, and quality data, so FAIR plus quality, and related resources. So this is not just data, it's also the stuff you need to work with the data, which might be applications or computational technologies. Consumed, produced, and provided. Again, people are both giving and taking in this data space by identified providers, identified participants. So people who play in the data space are known, and they're each kind of held to respect societal values. And I say that because it's often referred to as European values, and operating within an explicit framework of trust and governance. So there is, in the Commission's discussions about this framework of trust and governance, there's a need to create this, although there's no guidance about what that looks like. So it's just a bit of magic. So we'll talk a bit about that more. So the Commission refers to public data spaces, but you can actually imagine things being private, but we'll talk about that in a moment. It does not identify specific groups of actors or communities. So the assumption is that you have this big bag of participants. They are participating because they're all engaged in the sector, let's say agriculture, but they're not coming, the space itself is not purposeful. So if you look up above and you look at the agricultural data ecosystems, generally all of these organizations, Just Connect, API, Agro, DKE, AgriRouter, etc., they talk about their purpose. They talk about what it is they're going to do for the participants, and particularly for the farmers. When you talk about an agricultural data space, everybody hopes to get their own value out of this data space themselves, but the space itself is not created around a particular purpose. So this is something we need to keep in mind, because it creates a little bit of an issue as to what trust and governance might look like when we don't actually know why we're collecting this data into a big pile. The next point is that the Commission does aspire to a single common European data space. So their hope is that all of these sectoral data spaces can be grouped together into a big, gigantic bag of common data, and that it will all work together. And magic will happen based on that. But I think as researchers with experience with research data know that may be a little bit, that's a very aspirational and hopeful statement. It may take a bit of work to get there. So we do have the domain data spaces. So collecting data and data services relevant to a domain or sector. But you can also imagine a data ecosystem as essentially being a private data space, plus adding in community and purpose. So we want to respect all the things that are in the data space definition: findable, accessible, interoperable, reusable, quality, availability, related resources, identify the participants, respect societal values, operate within an explicit framework of trust and governance, and explain who's part of this data ecosystem, and explain why they're part of this data ecosystem. So that's why there's that asterisk next to FAIR, because the definition of FAIR assumes a certain amount of openness in some of this information. So we're kind of bending the definitions a little bit by talking about a private data space. So two very different concepts, but maybe we can come up with a single unifying approach to talk about things, so we don't always have to specify whether we're talking about a data ecosystem or a data space. So we've come up with the phrase data exchange approach. We're not saying that's especially the perfect name. I think the Big Data Value Association also talks about data sharing spaces, and this might be a good balance, a similar kind of concept that encompasses the two concepts, the range of possibilities. Certainly, a data exchange approach has both organizational policies and roles and technical specifications. And both of these pieces are needed to enable this trustworthy exchange of data between two partners. So ecosystems and spaces are themselves types of DEA. So we can identify some characteristics for all data exchange approaches that helps to define the different kinds of data exchange approach. And one very useful characteristic is visibility. So who's allowed to see the data? Who's allowed to see the metadata? Clearly, in the world of research, we aspire to open data, and we aspire in a fair environment to as open as possible, as closed as necessary. So the presumption is that it's publicly visible to the extent that that makes sense. And certainly that the metadata would be publicly visible. As we move to data spaces and we move to data exchange ecosystems, clearly there's a need to tighten this visibility up. And I think this is one of the problems that in the industry world, people are having trouble with. They haven't really come to grips with the fact that there are different groups of people who want to share data. There isn't really a discussion about visibility up front. And so there's a certain amount of confusion and hesitancy because they're worried that their data is going to be exposed to everybody. So we want to define the visibility of the data space. We want to define the visibility of the data ecosystem that we're talking about. And the same applies in the science community. So we have virtual research environments, you have research communities, research platforms, and generally there is implicitly a limited visibility. Not everybody gets access to a given research platform. It's usually handled in a quite straightforward way, namely the AAI system is what says who gets to see inside the box and who doesn't. But we call that visibility. So I think that helps us to understand that. A quick side note, many of you are obviously very familiar and involved with the European Open Science Cloud. And this is an architectural diagram, I think, that came out of EOS Future. And it's kind of a useful kind of status check to say, okay, where, are there data exchange approaches inside the vision for EOS? And in fact, there are lots of them. And all those things that I've marked in red are essentially, each of them is a data exchange approach. And each of them has its limited visibility. They have implicitly or explicitly some governance and some trust assumptions about how people are working with data. And then there are questions of purpose. Why are we doing it? Well, we're doing it because we want to share climate modeling data, or we want to work with biodiversity data. So there's a shared purpose in each of these areas. But then as you go from the top of the diagram down to the bottom, where this idea of an EOS core, which is available to everyone, and this is it becomes more like a common open data space. So generally visible to the public and across the science communities, maybe not fully interoperable, but certainly well-defined from an interoperability standpoint. So not everything might work with everything else, but we at least have a well-defined set of metadata standards for every little piece of data and resource that exists at the lower levels, at the core level. So what are some of those key characteristics in addition to visibility? So obviously visibility has a security component. If you're allowed to see things, and then conversely, if you're not allowed to see things. So we have to make sure that security works. The four FAIR guiding principles are built right in. So I won't dwell on that. I think everybody on this call probably knows, many of you probably know 10 or 20 times more about this than I do. One thing that is discussed in science communities and in the data ecosystems is the idea of quality and fitness for use. This is a kind of a fifth important quality for data, or characteristic of data. Is it good quality? And some data ecosystems in the research world certainly have mechanisms that contribute to quality, that actually allow the community to say this data that we're working with is actually quality data, and we can use it. We can, not only can we share it, but we can rely on it being high quality. And then over on the right, we have essentially the three dimensions of trust. So what is the community? Who are we being asked to trust with our data sharing and exchange activities. Why are we doing it? What's the purpose? And what are the rules we've all agreed to? And these could be simple or they could be complicated. So there are really three dimensions to trust in a data exchange approach. And as I've kind of implied, we have a spectrum of data exchange approaches from the very simple data exchange agreement all the way on the far left up to open data on the far right. And this is data exchange agreement is a classic one research project contacts another research project, researcher to researcher, and basically they enter into a data transfer agreement. So this is researcher A and researcher B saying, I'm going to give you some data because you've agreed to my rules, and we can do it that way. Or we go all the way to the far right, open data, where we're publishing everything, and we work on that basis. So quickly exploring this, I just mentioned this data transfer. There's a specific document or piece of paper that says an agreement for each exchange. We extend this to a data ecosystem. There are multiple members in the community. We arbitrarily give them letters. And basically, instead of there being a data transfer agreement between two parties, everybody is agreeing once to the ecosystem's governance, namely the rules, policies, and specifications. There's also a metadata catalog, which is private. It's only visible to the data ecosystem. And there are specific use conditions for exchange. So it may be common, maybe just kind of a CC BY or CC BY ND type of structure, a license, or there might be more complicated things in some environments. When people talk about merging two different ecosystems, I throw up a red flag and say, well, in fact, there are several questions that need to be answered. Just because everybody's sharing within an ecosystem doesn't mean they're necessarily prepared to share data across two different ecosystems. They need to harmonize their two sets of policies, rules, and specifications. There's questions about exposing the metadata, and they need to align on their use conditions. So one may have a sort of a CC 4.0 type of structure in terms of licensing, whereas the other one, for example, the Global Alliance for Genomes and Health, have a really complicated data use ontology, which talks about some very specific issues about what you can use the genetic data for. Are you using, and I won't even get into it, it's quite complicated, but the point is they have that specified in quite a lot of detail. And the two, it's like oil and water. You have to manage this alignment of the two sets of use conditions. Some people propose a federated data ecosystem to solve these questions of alignment between separate data ecosystems. And to some extent, this is what Gaia-X is about. And this is also, I think, what we see going on in the European Open Science Cloud, where there's implicitly, it's not being exposed directly, but I think what needs to happen in the European Open Science Cloud is that the different science communities need to figure out how to align their governance, their exposure, their catalogs of data, metadata, as well as their usage conditions, and figure out if there's a subset of things that they can all agree to so that they can share data across the research communities. When we move to a public data space, we don't initially identify who's playing, who's looking in the data space. So there are question marks down below. We don't have identified parties, but once people actually do agree to a transfer, there is an identification of who somebody is. But again, we have an agreement to the rules. There's a public metadata catalog. So you have to be sure that anything you're putting in there from a metadata standpoint is actually suitable for that public exposure. And that's actually an issue in many industrial ecosystems. They have problems with that. So there's a real question there. And then exchange specific use conditions. And finally, we have the open data environment, which in the research community, we've talked quite a bit about this. So important issues, every one of these different data exchange approach is separate and distinct because it has different rules, it has different use conditions, it has different mechanisms around the handling and exposure of metadata, different amounts of visibility. So we can't assume that they're all just a vanilla, the same kind. We have to look at them, and there's a sovereign decision by the holder of the data about where to put that data, where to expose their metadata, and where to expose and potentially share and exchange their data. So with regard to data exchange, we have not looked at intermediaries. We've assumed that everybody's holding their own data and transferring it back and forth. Now, one of the things we are working on is an extension of this concept, these kind of general concepts, to look at the different shapes that data sharing, data exchange might take, the role of intermediaries, the role of repositories, whether there are push or pull modalities in terms of data exchange. So we do want to refine our model a little bit to capture some of that. And of course, the role of data intermediaries is important, because if you are a repository, if you're holding data from lots of original providers, you become a data intermediary, and there may be some obligations there. And if you look at the Data Governance Act, in fact, there are some potentially legal obligations there in terms of enforcing the use conditions that may be set by the original data donor who put it into your repository, and saying, well, don't allow anybody to use this for commercial purposes, let's say. And then it becomes a job of the data intermediary to actually enforce that and to supervise whoever might download the data and make sure they don't engage in commercial activities. So it's a little fuzzy there right now, because that's a pretty hard obligation on the part of it for a data intermediary. And the last question we have in terms of the sort of topology or the architecture is, how do we model the bringing of compute to the data, which is something a lot of people are discussing. Federated learning, it's basically a bringing of compute to the data. So in my view, at least, it's a service. You're not exchanging data per se. You're providing a service and delivering certain things there, but we have to sort of refine some of the language there. So getting a little more specific data exchange approaches, I wanted to call out a few. There are 13 data spaces working inside the AGIS project, and many of these are data ecosystems. They're a little bit more narrow in terms of their visibility. Some of them are very much basically the equivalent of a public data space, and we examine these in a working document that we're preparing right now. And then you compare that to some of the other things, such as, for example, I mentioned federated data ecosystems. And research already provides public data spaces. So 3 of these that we've explored in our case studies: IS, ENIS, GBIF, and CDataNet. So I think the research world is using different data exchange approaches. Some are true public data spaces, some are more data ecosystems. They have their distinct communities and their own governance, and we can't assume that everybody can just magically switch to some new regime, because in many cases it's taken decades for this research community to learn how to work together and to agree amongst themselves about how they're going to work with their data. So we shouldn't trivially assume that it's easy to change those rules in a few days or a few weeks. So that's kind of where we are in looking at the conceptual underpinning for this. And I think I'm going to hand it over now to Andrea, who's going to take some of the characteristics that I've just described and explore how some of the tools and services inside AGIS actually allow those required characteristics to be implemented. So there you go. Thank you very much.
Thanks a lot, Mark. So I'm going to, I don't know why my video sharing is not working, but at least the screen sharing is going to work out, hopefully. So let me share my screen. Oh, sorry, wrong sharing. Can you see my screen?
Yes, we can see it
Yeah.
very well.
Thanks a lot. So basically, so after the presentation from Mark, I would like first to introduce you for those who are not, doesn't know the AGIS project. So a little bit of introduction of the GIS, and then as Mark said before, previously, we would like to map a little bit the characteristic of the data changes approaches that previously reported into the AGIS services. And then I would like to introduce some of the services for AGIS Data Spaces that we have, for instance, to AGIS Check-in and Data Hub, and do examples of data spaces that are quite advanced at the moment, so already ready and accessible to users. Of course, so starting from AGIS, the project is as objective the implementation of the compute platform for the European Open Science Cloud, and this contributing also to the EOSC Data Commons, and this is done by delivering computing platform, data spaces, and tools all integrated. And this is with the aim also to be aligned with major European Cloud Federation project and the HPC initiatives. The project is coordinated by the Java Foundation, and basically with a big consortium with the most, I mean, more 57% of the budget allocated to service provisioning. And of course, we have different partners which provides cloud, HTC, and HPC resources or services for data spaces, as we're discussing today for this topic. This is the architecture of the GIS project that we deliver. So it's a service tiers service architecture. So on the bottom, there are the federated resources, which corresponds to compute and storage, HPC, HTC, public cloud, or research cloud. We have a layer then of federated access, which so a federated compute, identity, and federated data, and which are used by platforms which will deliver generic added value, like workload manager, distributed AI training, or automatic cluster deployment. And then on the services that are on the tier, the bottom tier are integrated by data spaces and early adopters on the top. And all of them, of course, we deliver also tools like for service management and of course policies and processes, of course, which is vertical on this. And all the services that we provided are delivered to EOSC users via the EOSC portal. I put here like a long list of services which are provided by 60 different. So we have 61 services. So some of them, provided by more than one provider. So in total, 31 provided by 61 organizations. We have so today, as I said, we mostly try to map what are the characteristics of the data exchange approaches introduced by Mark to the services that we deliver in AGIS. So in particular, we created this table, try to map a little bit what are the characteristics. So we deliver, so basically, as said before, we have like one of the characteristics of the data exchange approach is the visibility and security. And of course, one of the services that delivers this in AGIS, it's the AGIS Check-in, which includes also Perun and Master Portal as components. All the first characteristics of findability, accessibility, interoperability, and reusability, it's mainly delivered by the Federated Access Service, so Data Hub, Rusi, and OpenRTM. And of course, then characteristics like quality on purpose are specific to the community, which is in the data space. And the community aspect, again, is implemented by Check-in. And the governance, of course, is something that is set up by the community that's built in data space. Plus, of course, we have like some some part of it which is delivered by the accounting component in AGI and the AGI check-in, of course, because the governance requires also not to understand who access the resources and audit. So this is delivered also via accounting. So I said before, I'm going to explore a little bit 2 examples of services, which as I said here we are reported. So the check-in and the data hub. So the check-in service, you find for sure a lot of information about the service and more details in the webinar that we had some months ago in the AGI webinar series given by GRNet people and Valeria from AGI. It's a proxy service that operates as a central hub to connect related identity providers with the AGI service providers. And the main characteristic of the service are that there are like multiple federated authentication sources enabled using different technologies. It's federated into gain. It allows also accounts linking. It is compliant with the ARC blueprint, and there are like by integrating it with the RC out and master portal, you can also use it in non-web use cases and also in providing delegated access. It has, in particular for the data spaces use case, it's important that there is also a possibility to operate group management service. So there's no need to have the community to bring their own group manager capabilities, because they're implemented also in the check-in. There are 2 types of those. So there's the co-manage and Perun. And this avoid, for instance, the overhead of deploying this dedicated group management service. And then the BO, in case the data space, the admin of the data space can manage the information about the users independently. And this can be used, of course, both in the case of AGI, so AGI services, but also for non-AGI services if they're integrated with check-in. The other service that we identified, of course, for the AGI data space services is that hub. Also link here one of the presentation, the recent presentation that Lukas took from Cyphernet as delivered at the AGI conference 2021. So it's data collection aggregation service because it allows aggregating data coming from different providers based on this one provider component, which is deployed on top of storage resources, which can be, for instance, as I put in the figure here, like S3, Swift, or Gluster. It allows to build also a data repository because the data that are stored in the Data Hub can be easily shared for anonymous access. They can also be, it includes built-in an OAPMH service for metadata harvesting, and it can also include functionalities like PID and DOI minting. It builds inside also a metadata indexing service, and there's possibility to plug portals for data discovery, which is a Redux plugin. And in general, it delivers a platform for hybrid cloud data management and also a processing environment. Some features that I extrapolated like 2 features that for sure for the building of data space and which are describing so the characteristic of metadata repository, metadata management related to this functionalities. So for instance, as I said before, there is like a possibility to have metadata associated to files, and this is integrated in the service. The possibility to have custom user metadata and the API for managing them. So as in the example here, we can access, include the metadata to a directory or to a file, and having API, to deliver this functionality, both for the metadata handling and for the data discovery based on metadata, and also the creation of virtual folders based on metadata tags. And then on based on having this functionality to have like metadata associated with files allows also to implement data discovery plugins, like simple ones, which can be used in order to filter and search over the collections that are stored in the tab. There is a screenshot of the possible interface which can be delivered with the tab. So then, after introducing this example of services that can be used to build the data space in the AGIS that are currently used, by some of the data spaces, I will introduce also a little bit 2 examples of those. So in total, we have 13 data spaces in AGIS, which are divided in 5 different domains. So the humanities, health and medicines, climate research, energy and physical science, and environmental sciences. And together with this data space, we also have 7 early adopters. The first one that we would like to describe is the NS data space. As I said before, these are examples of some of the more mature data space which are available and already registered, for instance, in IOSC. There's been also a recent presentation about the NS data space at the AGI conference 2021. So I took some of the slides from this presentation. For instance, we have the goal of the data space is to have an entry point to a scalable cloud-based data science environment for climate data analysis. This is, of course, built on top of the IOSC compute platform delivered by AGIS, the AGIS. This a specific use case is for the data that are coming from this project, so the CNIF 6. And the data space is kind of entry point for the data sets, as I said, the coming from this project, which are pre-staged, driven by users. So there is a way to basically ask for specific part of the data sets to be pre-staged on the resources provided by AGIS, both storage and compute. And then on top of this, there are a lot of customization for the deployment of data science software stack, IDs and applications, and everything is cloud enabled. So we have like a software as a service and user application, and also possibility to use some of the components like orchestrators in order to deploy and perform data analysis. In detail, of course, as also Hin introduced at the beginning, there will be a dedicated webinar in 2 weeks about the NS data space. But the data space is already accessible, and basically is part of the services registered from AGIS in the IOSC portal. And it says, so just to tell you that what has been implemented is possibility to download and cache data sets that are coming from the ESGF, so the Earth System Grid Federation, and then of course build on top of this a data space environment which integrate AI, so AGIS, and that access service via the tab. The more in details, these are the technologies that have been integrated. So Data Hub from AGI, of course, with Docker as well from AGI, AC3, and a lot of different system for data analysis and for monitoring. And the users, of course, can access the service using the Jupyter Lab or kind of with predefined notebooks, which are also available via Gallery. And they have the possibility to request data set to be pre-staged and available via a data request form. The second example of data space that I would like to show today is the Prominence data space, which is also put a link here of the recent presentation that's been given by Andrew live at the AGI conference. So I've taken some of the slides from what has been presented. So this is based on Prominence, which is a platform to run batch jobs and workflows across multiple clouds. It has been developed by the UK Atomic Energy Authority. This is basically it's a platform which tries to basically avoid the different type of cloud or where the jobs can run, so local, community cloud, the federated cloud, or the HPC as well, or the public clouds, and with a series of different access modes for the users, so CLIs, web, Jupyter, Lab, or REST API. And has been developed also since in collaboration also with other projects like EOS Cab and EOS Pilot. The goals of the data space is to build neural network-based surrogate models in an efficient and effective manner. In this case, what they're trying to do is to build a physics informed neural network with the possibility to implement a cyclic workflow for the to inject simulation to request simulation parameters and get simulation data when training the machine learning training. And basically this is the architecture. So we have like that's been deployed in the AGIS. So we have the Prominence framework, which is basically connected with the 3 different sites, SESNet, Tubidac, and ICT Bus. One of these is HPC, so ICT Bus, and two of them are cloud-based. And the access to the data is given with the AGI Data Hub, and of course the access to Prominence via AGI check-in. One of the sites is also providing also GPUs. What the characteristic for the data space? So the data access in Prominence is given as before integrated with Data Hub One Data. So the jobs that are running are mounting Data Hub storage. This can be done either via directly using the Fuse mount or using the REST API, which is the preferred way in HPC resources. And in order to basically discover the data, they have included specific JSON documents attached to a files, as I previously mentioned, one of the features that One Data delivers. They also implemented data distribution between sites. So this is one of the characteristics for data exchange. This is something that can be performed either automatically by One Data or using the QoS to specify the QoS rules. Of course, also in a way that we can have bulk replication of when needed. This is, for instance, an example of bulk replication between the 2 sites. And then, of course, as I said before, I just have given like examples of data space that are delivered in GIS, but of course there are more that are, as I said before, the 13 in total that we're building. So we have more example in the AGI conference session that I put a link here, and services that could be used for the building of data space. For instance, the data management in AGI with Russia and FDS memories. I put a link here just to give you some example of other resources that you could check and services that can be used. For instance, there will be also, as Yin said at the beginning, a webinar for OpenRDM on the 12th of January. And there is also a session. There has been also a session at the AGI conference about the federated access services, which gives you an overview also of the services that we're going to use in AGIS. Okay, this is now we have time for questions. So